All right, let's dive right into this explainer. Look, if you're a developer or an engineering leader right now, you are probably feeling a very specific kind of frustration. I mean, we've been promised this magical future of AI coding assistants, but the reality, it kind of feels like we're spending half our day just trying to get them to understand what we're actually building. Today, we're unpacking a fascinating breakdown from the team at Unblocked. They reveal exactly why we're stuck in this rut, and way more importantly, how a new architecture, known as the context engine, is stepping in to completely solve it.
So, I gotta ask, are you just completely tired of babysitting your AI agents? Because right now the standard workflow is basically a doom loop. You spin up an agent, you give it a task, it writes some code that looks, okay at first glance. But then you realize it completely hallucinated a library, or it totally ignored your company's internal patterns. So what do? You correct it, you paste in 3 different markdown files to give it some context, and you try again. You are literally doing the care and feeding for an entity that acts like a brilliant day one employee with absolutely zero context about your company. Okay, here's our roadmap for today's explainer. Number 1, the babysitting problem. 2, the ladder of AI adoption. 3 myths about context. 4, the context engine architecture. 5, truth, conflicts, and outcomes. And 6, hard lessons from the trenches. Let's move straight into the mechanics.
Section 1. The babysitting problem. The day one employee.
Think about what actually happens when you type a command into your CLI to spawn an AI agent. Honestly, it's exactly like hiring an absolute genius engineer right out of school on their very first day. Sure, they know how to code, but they have absolutely zero organizational knowledge. They don't know your pull request history, they don't know who the experts are on your specific team, they definitely don't know about that weird microservice you built 3 years ago. When a human engineer joins, they build this context over time, through meetings, getting PRs rejected, asking a ton of questions. But an agent? An agent is completely lost without you manually feeding it that information. And because of this, you, the human, are forced to act as the context engine.
Moving on to Section 2, the ladder of AI adoption. Where are you?
So there's a clear ladder of AI adoption happening in the industry right now. Step 1 is what we just talked about, you acting as the manual context engine. Step 2 is using fancy autocomplete in your IDE. Now Step 3 is where a lot of forward-thinking teams are currently stuck, static curated repos. This is where teams create dedicated folders full of markdown files, like agents.md, trying to document all their corporate context for the AI to read. But honestly, it's a trap. These files are static. They require constant manual updating, and they completely miss the raw runtime data that real engineers rely on every single day. The ultimate goal we need to reach is Step 4, dynamic context engines.
And this brilliantly illustrates the core thesis of our explainer today, perfectly captured by this quote from AI researcher Andrej Karpathy. The gap is not intelligence anymore. The models, they're incredibly smart. The actual gap is context. Our agents have the brain power, they just don't have the institutional memory required to do the job right.
All right, Section 3, 3 myths about context, busting false assumptions.
Right now, there are 3 really popular myths floating around the developer community about how to give agents context. Myth number 1 is that simply pointing a standard RAG or Retrieval-Augmented Generation system at your docs is enough. Myth number 2 is that giving an agent API access or Model Context Protocol MCP pipes to your tools equals understanding. And myth 3 is the dream that just shoving everything into a massive 1 million token context window will magically solve the problem. Let's break down exactly why every single one of these fails in a real-world coding environment.
Let's use a medical analogy here to put this into perspective. Satisfaction of search. So if a radiologist is scanning an X-ray for a lung issue and finds one abnormality, they often just stop looking. They're satisfied they found the answer, potentially missing the actual root cause. Well, naive RAG agents suffer from the exact same thing. If you ask an agent to build an integration, it grabs the very first document that looks relevant, and it just stops searching. It isn't exhaustive. It completely misses the nuance, leading you straight back into that doom loop of manually correcting its mistakes.
And then, well, what about myth 3? That glorious 1 million token context window. I mean, we all dreamed this would be the silver bullet, right? But actually, stuffing a massive window full of raw code doesn't provide any relational understanding. The agent just sits there without knowing the entities or the relationships between the data. Worse, asking an agent to endlessly grep through massive code bases in a single session burns a bajillion tokens. And the most painful part? The very second you close that terminal window, all that wildly expensive context is gone. Poof! Bye-bye! You have to pay to do it all over again next time.
Which brings us to Section 4,
The context engine architecture. How to fix it.
So the absolutely crucial point here is that a true context engine is a distinct architectural layer. It sits right between your human engineers, your data sources, and your AI agents. There are 6 really distinct differentiators at play here. It doesn't just read static files, it actively reasons across all your systems of record at runtime. It performs targeted, exhaustive retrieval, so no more satisfaction of search issues. It securely respects data governance, meaning if an agent searches on your behalf, it only sees what you have permission to see. And crucially, it optimizes tokens, compressing massive corporate knowledge into the exact small response the agent needs to act, saving you massive compute costs down the line.
But honestly, perhaps the most powerful part of this entire architecture is the social graph. Basically, a context engine procedurally generates a node graph of your entire organization. It knows exactly who the developer asking the question is, it knows their pull request history, what code bases they usually touch, and who they collaborate with. So if you say, hey, fix the bug we were just talking about, the engine dynamically pivots and personalizes the query. It knows exactly what that bug means to you versus what it would mean if a totally different engineer across the floor asked the exact same question.
All right, Section 5, Truth, Conflicts, and Outcomes, putting it to the test.
You know, one of the biggest challenges in literally any company is conflicting information. Just imagine an agent looking at the source code running in the main branch. Normally, you'd think that's the absolute truth. But what if there's a recent conversation in a Slack channel where the CTO explicitly states that the implementation in main is wrong? A context engine actually has the reasoning capability to settle that debate. It weighs the social graph, recognizing the authority of the CTO, and intelligently overrides the literal source code, passing the actual current truth to your AI agent.
And this translates directly, and I mean directly, into code quality. The Unblock team actually ran a test where they asked an agent to build a Zendesk integration. They gave one agent naive API access to all the tools, and they gave another agent the context engine. Well, the naive agent wrote code that successfully compiled, sure, but when put up for review, the senior engineer rejected it completely. Why? Because it ignored the company's specific factory patterns and would have broken the system. The context engine agent, however, it exhaustively researched the company's patterns first. It wrote a comprehensive plan, executed it, and the resulting PR was literally just one minor nitpick away from being merged by that exact same senior developer. That is the massive difference between mere access and deep understanding.
Finally, Section 6, Hard Lessons from the Trenches, What Not to Do. The engineering team shared 3 major what not to do lessons based on real-world experience. First, as we've seen, don't optimize for access over understanding. Second, don't hide source conflicts. If the docs and the code disagree, the system needs to surface and resolve that, not just randomly guess. But this third lesson, it's absolutely critical. Never cache good answers just to speed up latency. Why? Because code changes rapidly. If you cache a perfect answer today and the codebase changes overnight, tomorrow your context engine will confidently lie to your developers. Real context has to be dynamic always.
And really, that brings us to the ultimate goal of all this. We absolutely need to stop treating our AI like a brilliant but completely helpless newbie. With a properly architected context engine, one that actually understands your social graph, resolves truth conflicts, and exhaustively retrieves information, your AI agents should write code that feels like it was written by a veteran team member who has been with your company for years. We should expect our AI to be a seasoned colleague, for sure, not a day-one employee.
Which leaves us with arguably the most important question for your own engineering teams right now. As you move beyond simple autocomplete and start relying heavily on background coding agents, how will you build true context for your organization's AI? Are you going to keep babysitting them, or is it finally time to build the engine? Thanks so much for joining me on this explainer. I really hope this helps you rethink your AI pipeline. Keep learning, and I'll see you next time.